In this video, we will be discussing the beginning of Chapter 8, Exponents and Exponential Functions, with Section 8.1 and 8.2. So let's go ahead and start. This begins on page 489 of your textbook. So in 8.1, we are going to be applying different exponent properties involving products. So please keep in mind that a product is the solution of a multiplication problem. Alright, so product of powers. So I'm going to be multiplying multiple pieces here that have powers or exponents. So let A be a real number, so it's any number. Alright, and let M and N be positive integers. So a to the nth power times a to the nth power equals a to the m plus n power. So if I am multiplying, I simply add the exponents as long as the base is the same. So I want to go ahead and mark a is the base, and m and n are exponents, just so that you know what I'm talking about when I say it must be the same base. So a must be the same. Alright, so looking at a couple of examples here, use the product of powers property to simplify. So what we do mean by simplify is you go ahead and write it with one simplified exponent, and then if it says to evaluate, you actually want to go ahead and multiply that through, and we'll go over different status quo rules here. So go ahead, pause your video, and see if you can use that rule to determine what these four solutions are. Okay, so if you go ahead and look at these solutions, I did show my work. The only thing you need to be super careful about is, what if you don't see an exponent? So these three situations that I'm highlighting, their exponent is 1. So if you don't see an exponent, that means there's only one 8 there, one -3 there, or one b there. And I don't know why I wrote all the way in the solution 5, but I did. Alright, so you need to include that 1 into your problem. Alright, so other suggestions is, if a number is in parentheses, leave it in parentheses. It is going to make a difference. I'm just going to let you know that -3 to the 4th power is different than the opposite of 3 to the 4th power. So this is read the opposite of, and this is read -3. Alright, and they're both to the 4th power. This will give you a positive 81, whereas this gives you a negative 81. They're not equal, so you need to be very careful about how you write those. Okay, so moving forward with another rule, power of a power. So first I have a power on the inside, and then I'm raising that to an additional power as well. So power of a power. Alright, and that a to the m to the nth power is a to the mn. So I am going to be multiplying. I'm going to be multiplying here. Alright, so looking at some examples using that property, I want to go ahead and give you a second. Go ahead, pause the video, and see what you can do by yourself. Okay, so when I have a power to a power, I'm simply multiplying the exponents. You can do what is called expansion, alright, which is a pretty long, tedious process. If I were to use C to use this expansion, I have y to the 3rd, so this is y times y times y. And then I have that's y to the 3rd. I have that 3 times. So you can write all of this out. However, it is definitely not recommended. It becomes a little tedious, and then what if you only miscount it, by 1, just by accident? So that's called expansion. You can, of course, use that every single time. Alright, moving forward, applying exponent properties involving products continued, the power of a product. So if I go back to my very first property here. It said, let me go back one more, product of a power, power of a power, and now this is power of a product. So the order does matter in what we're trying to accomplish. So this is a power. We typically work from the outside in. Power of a product. So I'm raising a product to a power. Alright, and that means that both pieces here in this multiplication problem end up getting raised to the same exponent. So let's look at an example. I'll work out example number 1 here. Alright, 34 times 9 to the 6th power is going to be the same as 34 to the 6th power times 9 to the 6th power. So why don't you go ahead and try the next 3 examples. Alright, so going over some of these solutions, make sure that you are distributing that exponent to every single piece of the product inside. So that does include the 4. Lots of people forget to include the 4 in that. They just distribute that exponent to the variables. So it is 4 cubed, m cubed, n cubed. And a hard and fast rule is that typically if there are coefficients and variables involved, normally they go ahead and multiply out and actually compute and evaluate that number. So 4 cubed, 4 to the 3rd power, is 64. And we're going to do the same thing in C here, where they take -2. I'm very careful to put that in parentheses. Parentheses always help. And I raise that to the 4th power, g to the 4th power, and -2 to the 4th power is 16. And then in this case, that negative is not in parentheses, so it's actually read the opposite of, and then you are squaring everything else. So it is the opposite of 5 squared x squared, or the opposite of 25x squared, so -25x squared. Moving forward in 8.1, simplify the following, so getting a little bit more complicated here. Just like in the last example, you need to make sure that exponent is distributed to every single piece of that product. So, following PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. I deal with my parentheses and my exponents first, so that's 3 cubed. And then I have d to the 5th to the 3rd power, alright, as well. And then that's going to be multiplied by another d. So I go ahead and I get 27, and that becomes d to the 15th, because I multiply, it is a power to a power, times d. There is a hidden to the 1st power, so my final answer right here, that is a product of powers. So I'm going to add my exponents, that is 27 d to the 16th power. And looking at another example, order of magnitude. The order of magnitude is a quantity that can be defined as a power of 10. Alright, that best describes the quantities. So we're talking about 10, 100, 1,000, 10,000, 100,000, 1 million. Alright, those are all powers of 10. So 10 to the 1st power is just 10, 10 squared, 100, 10 cubed, 1,000, so on and so forth. The number of the exponent is the number of zeros it has. So there are about 91,000 species of insects. The power of 10 that best describes that is 10 to the 5th power. Thus, there are about 10 to the 5th power of species of insects. So they choose 10 to the 5th, which is 100,000, instead of 10,000, which is 10 to the 4th power, because 91,000 is closer to 100,000 than it is to 10,000. And one more example using that. Example 5. A box of staples contains 10 to the 4th staples. How many staples are in 10 to the squared boxes of staples? So keep in mind you have 10 squared boxes. Alright, so that is 100 boxes, and there are 10 to the 4 staples in each box. So I'm going to go ahead and say that in each box, so here is each box, you have 10 to the 4th. And then you are raising that to how many boxes you have. Let me rephrase that. You're not raising it to, you're multiplying. So this is staples in a box. Staples per box. And this is the number of boxes. Number of boxes. So you are multiplying. So, using your product of powers, you get 10 to the 4 plus 2, or 10 to the 6th. That is a ton of staples. Alright, so hopefully that was enough examples for section 8.1. If you have any questions, please feel free to contact me via email or over Classroom, and I should be able to get back to you. Please continue to watch these videos and stay on top of your homework.